Okay, example 3, using systems of inequalities in our real life situations. So Malia has $500 to purchase water bottles and pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too many of just one item. What is the graph that shows the possible numbers of water bottles and pairs of socks that Malia can buy? So let's finish marking the text here real quick. Okay, so there's two things that we're talking about. We're talking about socks and we're talking about water bottles. So I'm actually going to make X represent water bottles and Y represents socks. Okay, normally a system, what we've been working with has been 2, but remember a system of inequalities is 2 or more, so we actually in this case have 4 inequalities that we need to talk about. Well, the minimum amount of water bottles that she can buy is 0. So we're gonna have X is greater than or equal to 0 because she can buy 0 water bottles or she can buy more than 0 water bottles. There's not really any negative 0 water bottle situation that she can do. The next one is socks. It's the same thing. The number of socks is also greater than or equal to 0. So before I even get into the other system, all this means is that I'm going to graph the system in the first quadrant, meaning my X is going to be all of the positive X's and my Y's are going to be 0 and all the positive Y's. That's all that means for now. So we don't really have to do anything else. It's just meaning to graph in the first quadrant where everything is positive. Okay, so now let's get into the other 2 inequalities for the system. The first inequality has to deal with the cost of the items and how much money Malia has to use. So let's see, water bottles, they cost $2. I found that from the picture. So it's going to be 2x plus, and socks cost $3 according to the picture, so 3y. She has $500 to spend and she cannot go over that. So that means that this 500 has to be a maximum. So the alligator has to eat the bigger number, but she can also spend exactly 500. So we'll put a less than or equal to sign there. Now the next inequality has to deal with the number of items she's going to buy. She needs to buy at least 200 items. So that means whatever she's buying can be more than or equal to 200. And the items that she's buying is water bottles and socks. So X plus Y. Now that we have our system, which is all 4 of these inequalities. Now that we have our system, let's start graphing. I already have my boundaries, so I'm not going to worry about that. I'm just going to go straight into the red inequality, this first red inequality. And I have to graph it in standard form. So I put a little table there to remind you to graph using intercepts. So we graph using intercepts by plugging 0 in for X. And if I plug 0 in for X, the 2X goes away. And I'm left with 3Y is less than or equal to 500. Now let's divide by 3 on either side. And when I plug that in my calculator, I get 166.67. So I'm just going to round to 7.7. And then the next one, I'm going to plug 0 in for Y, which means that 3Y goes away, and I'm left with 2X is less than or equal to 500. And divide by 2 on either side, and 500 divided by 2 is 250. Let's graph that before I do any more things. So I have a y-intercept at 166.7. So here's 160. I'm going to say it's right here somewhere. And then I have a x-intercept at 250, so that's right here somewhere. I also know that it's a less than or equal to sign, so I'm going to go ahead and just do a solid line from there to there. Okay, that's my first. Let's try our test point 0, 0. if I plug in, let's see, what color do I want to use for this? Let's do purple. 0, 0 is right here. If I plug 0 in for x with the 2, I get 0. So like 2 times 0 plus 3 times 0 is less than or equal to 500. Well, that gives me 0, that gives me 0. And is 0 less than or equal to 500? Yes, it is. So we're gonna come over here and we're gonna shade it all this way. Sorry, I like to sing when I color. Okay, now let's do the blue. So we're gonna plug 0 in for x, and these ones are my favorite because if you plug 0 in for x, we're just left with y is greater than or equal to 200, so you're left with 200. And now if we plug 0 in for y, I'm left with x is greater than or equal to 200, so I get 200. So for this blue line, I'm gonna have a x-intercept or y-intercept at 200 and an x-intercept at 200. And it's a solid line again. So I'm gonna go ahead and just connect all of my dots. Now let's check my shading. If I plug 0 in for y and x, I get 0 plus 0 is greater than 200. That is false. 0 is never going to be bigger than 200. So I'm going to go back up here and grab my little shading guy, and I'm going to shade everything above this blue line. Now recall that where the shading overlaps is our solution set. So it asked us what the graph was that represents the situation, and that right there is the graph that represents the situation. However, everything within the overlapped region, so the darker purple, let's see if I can emphasize that anymore with some color. So everything in this, there we go, this darker purple region is a solution. Okay, so then part B, using the graph, can Malia buy 75 water bottles and 100 pairs of socks? Explain. Okay, so there's a couple ways you can do this. You can plug those numbers in and see if both of them are true. Or we can see if that point falls in the shaded region. So let's see, water bottles represents X. So the point we're looking for is 75, comma, and 100. So let's go to our graph and graph that. 75 would be about here, and 100 is right here. So let's see. Does that black dot fall in between the shaded region? I sure hope that you said no, because it does not. It does not fall in the dark purple shaded region, so this would not work for this situation. Another way that you could have proven that is just using that blue equation here. If I do 75 plus 100, is that greater than or equal to 200? Well, that gives me 175. Is 175 bigger than 200? No, it's false. So here's what we're gonna say. We're gonna say, no, Malia can not buy 75 water bottles and 100 pairs of socks because the point does not fall within the overlap shaded region and does not make all the inequalities true. That would be a perfect explanation for why this doesn't work.